Howdy folks, I'm Luke, an instructor and video creator here at Covalence. Welcome back to my TypeScript tip series where I aim to clear up some confusion about TS, tackling the most common questions, and more importantly, those pesky errors my students ask on a daily basis. So in today's episode, we're delving into a cool concept, type assertions. If you're just starting out, you might find assertions a little tricky or even unnecessary, but rest assured, once you get the hang of them, they can be a powerful tool in your TypeScript arsenal. We'll discuss what type assertions are, how they work, and I'll share some nifty tips using them effectively in TypeScript. So whether you're a fresh-faced coder or you're well into your TypeScript journey, let's get you a firmer grasp on this concept. So let's dive on in. In TypeScript, type assertions are similar to typecasting in other languages, but they have some different syntax and rules. So in many programming languages, there's a concept called typecasting. This is where you explicitly convert one type to another, usually because the language requires variables to be of a certain type for certain operations. TypeScript, however, has something slightly different called type assertions. It's similar in that allows you to explicitly tell TypeScript what type the variable should be, but the big difference is it's mainly used as a development runtime check. As a development check and not a runtime check. So this means that TypeScript does not convert the types at runtime. It is only used to type information for checking the correctness of your program during development. This is very useful and helpful in scenarios where you, as a developer, have more knowledge about a variable's type than TypeScript does. For example, when checking fetch data, right? You have no idea what their API response is, but you can assert a certain type. So it's worth noting that unlike other languages with typecasting, type assertions don't perform any special checking or restructuring of data. It has no runtime impact. It's simply used by the compiler. So while type assertions can help avoid errors during TypeScript's type checking process, it will not prevent runtime errors generated by your JavaScript. So it's essentially use them responsibly, understand that they won't convert types at runtime. With that in mind, let's actually take a look at some. So in TypeScript, which again, I'll have a simple boilerplate up here. Use whatever you want, get your own up and running, or just check the description down below to clone this one. We have a basic way of doing some typecasting. We can have an unknown type variable, which we will see here is going to be assigned a string LOL value. We're going to mark it as unknown for our types, and we're going to say let the string length, which we know will be a number type once we get the length property. But if we try and daisy chain on .length, we don't get any autocomplete help from TypeScript because, well, we told it it's an unknown type. So we can use what is called a type assertion via the following. String, some value, dot, and we now have all of our lovely string properties. And there we go, we now have a type assertion written. So that's all they are. They're a way of telling TypeScript to treat some value as a string despite it thinking it's unknown. This is one possible syntax called the angle bracket syntax, which you'll see in more old school applications, I suppose. The more common one you're going to see is this alternative syntax called the as syntax, which is written like the following. This is the as syntax. I use it a lot because I do a lot of React coding, and especially when you're in JSX where there are already a lot of angle brackets that can lead to confusion via a element or a component with angle brackets versus a TypeScript type assertion. So the as syntax is preferred if you're doing any kind of React work. As far as when to use them, they're very useful for when you're dealing with the any type, for example. This is no different in code compared to what I had written as unknown, but again, any means TypeScript effectively turns off all type checking on any's when you're basically using pure JavaScript. So rather than use any's, you're better off using unknowns. But in the case you have an any, for example, if we had a function that did indeed fetch some data, TypeScript's going to have no idea what that structured data looks like. So it may come in as, well, I don't know anything. We can tell it, hey, no, you are actually going to be a specific type via a assertion as such, going, hey, I know the response from this API is a string. Probably not the case. Probably going to be some kind of interface or array of objects, for example, right? But in this simple case, we know it's a string and we can assert it as such to not run into any kind of issues. It is also very useful when you're dealing with union types. So if you have, for example, something like this, where you have a string or number could possibly be gotten from, not fetch data, but let's do like get ID. Some kind of get ID is the ID variable we're trying to get from this fictional function here that could return a string ID or a number ID. We're not entirely sure, so we can then use our type casting or type assertion, not casting, oh my goodness, not casting, assertion. We can assert it as the string type in these unions, which is very, very useful. That way, we can make sure the variable is a specific type from that union, and we can tell it, hey, it's not going to be a number in this case. We know it's going to be a string. Also, when you're working with DOM elements, it's very, very, very useful. For example, we had the following, const canvas equals, hey, document.getElementById. This get element by ID method For example, selecting the element ID of my canvas, it returns a HTML element or null if it didn't select anything, so you got to make sure it did indeed select something, but it will return a generic HTML element type. But with type assertion, we can say, no, this will be specifically an HTML canvas element, which means we can allow ourselves to now do the following, something like canvas.getContext 2D. So now we have all this lovely autocomplete help for a specific HTML canvas element and not a generic HTML element by utilizing type assertions. When you're doing vanilla DOM work, type assertions are a godsend. I use them all the time. And then finally, another common use case is accessing properties on objects which may not exist. So if we had an interface, for example, called car, who we know is going to have a color property of type string, we can have just a generic looking little object right here called vehicle, and we're going to tell TypeScript for now that it's going to be just a generic object. It'll have color blue and a speed of a Gorillion, which is my car. There we go. And we can say let color type string equal. If we try and just simply do vehicle dot, we get no TypeScript autocomplete because it just knows it's an object with the methods of objects, but not its specific properties. But we can type assert to say, hey, vehicle as type car has a color property right there with a string value. So this type assertion allows us, when we're working with JavaScript objects, we want to access properties which TypeScript isn't aware of, or doesn't think it exists. In this case, we use a type assertion to tell TypeScript to treat the object as a type that does not have this property. So you're not just, with your simple data types, you can assert your own interfaces and types and other things like that. So yeah, some cautionary tales about type assertions. We'll go back to our simple sum value unknown. This time, let's assign a number value of 5, and let's do the following. String length, which should be a number type. Take some value, assert it as a string, and access its .length property. You'll see here that TypeScript is completely fine and happy with our code here, but we know that at runtime, numbers do not have a length property, and this would throw a runtime error. This is what I meant by type assertions do not prevent JavaScript runtime errors. This is problematic code, and you could run into a lot of trouble if you're overusing type assertions and you're not checking your actual data types. Like, make sure you're actually logging something somewhere, and we'll talk about type cards in a different video, but you want to make sure that you're not overutilizing type assertions, as this is a common scenario that you can find yourself in that would really ruin you. So something else is kind of funny about them. If we had some value and we left it as a number of 5, and we wanted to, for example, change this to a string of type string, and we did the following, watch this, we can say, take some value, which we know is a number, let's treat it as an unknown type, and then I want to cast it to, or I said it again, assert it to a string type. So this is clearly allowed in TypeScript, but it's illogical and doesn't make sense. So TS allows you to assert between completely unrelated types, which can lead to logical errors in your program. This is weird to even look at. If you're doing this, you're probably doing it wrong anyway. So don't overuse it has been the cautionary tale here. Right? So just always ensure that you're asserting things that make logical sense in the context of your program, and don't do shenanigans like this. So yeah, that's pretty much like the gist of it, I'd say. That's a wrap on it, right? It might seem like a lot to digest, but remember, these are just tools in your disposal to aid in cleaner and safer development code for assertions anyway. We've gone from looking what they are, they're 2 different syntaxes, identifying how and when to use them in most common situations, and some cautionary advice on when not to use them or overuse them. So don't forget to experiment with what you learned today. Always keep refining your skills. Your questions are always welcome, so don't hesitate to reach out. If you found this video useful, give it a thumbs up, drop a comment down below, and don't forget to subscribe for more TypeScript tips. Thanks for tuning in, and happy coding.